Right. So, Shayna, and you know we could apply logs to bring a power to the side? Some of that is yes or no.
Yes,
And
sir.
so we're gonna convert, right? So converting exponential equations into a linear equation. Now, Serena, do you know the form of a linear equation? I'm not hearing you, Serena.
So,
Y is equal to mx plus c, you said?
yeah.
Right. So, Shayna, do you understand that no linear equation has a has x to a higher power than one? If you have a higher power for x is quadratic or something like, let me give you an example, for instance. If I have x squared, would I call that a linear equation?
No, sir.
Nah. Right? So anytime you have x raised to some power, it's an exponential equation, right? Just keep that in the back of your head. And so Shayna, if I apply logs, I'd be able to take the power and move it to the side. And in doing that, I could get it to be a linear equation. Right? So it have two general cases you will need to be familiar with. So these are the two cases. So case one, y is equal to ab to the power x. That's one case. And the other case is y is equal to ak to the power n. Can we all agree that um in either one of these that don't look like y is equal to mx plus c? Can we agree that it does not look like y is equal to mx plus c?
Yes, sir.
Yeah, that don't look like mx plus c, right? Right? These, so I would call these exponential equations. These are example of exponential equations. And we want to convert that into a linear form. Just a recap, a linear equation takes the form y is equal to mx plus c. So there's no power for a linear equation. So let's look at an example. Right, so Shayna, I can already tell you how this going to go, right? Exponential equations have powers. We want to get rid of the power to make it look like this. So obviously, what I have to apply on both sides to get the power to the side. Thomas Shayna,
Logs.
now I have to apply logs. Great. Before we continue, right? Do you all know what M is? M stands for the what?
The gradient,
And C stands for the what?
the y-intercept.
Right. The y-intercept. Lovely. And Y would be whatever is on the y-axis, and X would be whatever is on the x-axis. Yeah?
Yes, sir.
Great. So let's look at an example. What if I said convert y is equal to ab to the power x into linear form? Let's see how that would go. Right? So y is equal to ab to the power x. So Shayna, what's the big problem over here? What's the big problem over here? See if you can figure that out. What's the biggest problem there? Shayna? We know for sure that not looking like y is equal to mx plus c. What's the biggest problem there? Can you see it? Serena, what about you? Could you see it? Could you see the biggest problem over there?
I'm not sure.
All right, Serena, remind me what the linear form looks like.
Y equals mx plus c.
Aren't these two looking very different?
Yeah,
Um, where is x over here? And x is to the side, and it's not a power.
yeah,
But in this case, x is a power, and
yeah.
so if I wanted to bring x to the side, right? If I wanted to bring x to the side, what would I need to apply in this equation?
You need to apply the log function.
Yeah, we need to apply the log function. So I'm going to use LG, right?
Mhm.
So I would say log y is equal to log AB to the power x. Did that confuse you?
No, sir.
And why do you think I'm adding logs on either side?
So that you could bring the power of x to the side.
Exactly. So let me ask you this, Serena. In the next line, am I going to write x log AB? Am I going to do that? Yeah or no?
No, because x is is the power of b and not ab.
Ah, perfect. Sheena, did you hear what Serena said?
I'm here, sir.
Um, Sheena, in the next step, could I take x and move it to the side and say x log AB? Tell me,
Yes.
you guess so. What if I tell you you can't do that? Would you know why you can't do that?
No, sir.
What does the power rule say? Remind me of the power rule. That'll be log base A. What? Remind me of the power rule.
Log is A, log is B, to the power N equals N log EB.
Okay. In this instance, wasn't the entire argument raised to the power n?
Yes, sir.
Okay. The argument here is AB. Is the entire is all of AB being raised to the power x?
No, sir.
What's the only thing being raised to the power x?
B.
Right. And as a matter of fact, what do we have inside here? We actually have A what bx. Well, what do we have? Addition, subtraction, multiplication. Tell me, Sheena, what's the relationship between A, B to the x?
Multiplication.
Okay, so I want you to keep that in mind. So can you see it clearly now? Yeah or no?
Yes, sir.
So we are seeing multiplication. Which rule could we apply but in reverse? Tell me, see if you can figure that out. Um, Sheena, anytime you have a product of arguments, what could you do with that? And you're real quiet today.
So you could use the product law in this, like,
Yes, I can use the product law in reverse. And so if I use the product law in reverse, I'm going to write log what? I'm a fast Sheena. Don't be quiet. We're moving on speed today. I want to finish log Susan and indices today. Sheena, hold on, Sheena. Serena, what would I get?
Log a plus log bx to the power of x.
Right. And in the next line, what can I do?
You could write log A plus 2 log B.
Say that again. I'm starting to not hear.
2 log B. I mean,
Two,
not 2.
two log B.
X log B, my bad. I don't know where the 2 came from.
I don't know. That's always confusing, ma. Right? So x log b. And remind me, what does the equation of a line look like again?
Y equals mx plus c.
Okay. So in the equation of a line, we have y. Now is y unknown? Okay, so is y a constant or is it a variable?
Variable.
Okay. Is log y a variable?
Yes.
Yeah, because and if I could change the value for y and get different output,
Yeah.
right? Um, look at where the mx is. Do you think this is the mx or do you think this is the mx over here?
Mm, the second one is mx.
Right? I'll explain what I mean by that. Now, a would actually be a constant. So log a would be a constant answer. So that's c. What do you think m is? If we're comparing terms, what do you think m is?
M would be log B.
Right. And x would just be x. Perfect. So the last thing I'm going to do before I write my final answer, I'm going to say log y is equal to log b by x plus log a. Okay. So tell me, Serena, does this look directly in the form y is equal mx plus c now?
Yes.
You can see it for sure,
Yep.
right? So log y is taking the place so y is taking the place of log y, right? M is now log b, x is just x, and the constant term is given by log a, right? So if that's the case, Serena, if that is the case, what would be my what would be on my y-axis and what would be on my x-axis? Let me see if you can figure this one out.
Um,
Try to speak up a little bit. I'm hearing you.
what do you mean by what would be on the axis?
Let me show you. So in y is equal to mx plus c, whatever is over here would be on the y-axis. Whatever is over here is x-axis. So keep that in mind, right? Remember that. Apply that same concept over here. So normally you put y here and x over here. But what is taking the place of y? Tell me, Serena.
Log y.
Right? And well, in this case, what is x? Just x, right?
X. Yeah.
So let me explain the gist of this thing. Tell me, Serena, if I use this function and I put in values for x, am I ever going to get am I ever going to get a graph for a linear function?
No.
No. So you understand you can't plot y versus x. You understand that.
Yes.
But if I were to plot log y versus x, I get a straight line graph. And the gradient would be log b, and the y-intercept would be log e.
Yes.
Yeah. That is what I'm trying to get at. So let me show you what I'm talking about. So let me do a sketch of the graph. Right. So if I did a sketch of the graph, then you see this over here. That's the y-intercept. This is the y-intercept, right? And that would be equal to log a. So c would be equal to log a, right? And the gradient would be equal to what? Tell me, Serena.
It would be equal to log bx.
No, log b.
Oh,
Remember, x is a variable.
okay. Yeah.
Basically anything other than x and y is a constant. Yeah, keep that in mind.
Okay.
And any gradient, I mean, any gradient is a constant, is a number.
Yeah.
Yeah. So keep that in mind, right? Yeah. So let us soak in a bit. Um, Tell Machina, is there anything you did not understand?
So I'm gonna drop out twice, like my Wi-Fi, but I think I'm following.
Okay.
Yeah.
So look at it, absorb it. We're going to do a different example, and I want you to stay unmuted and we'll run through it together. All right. Did you soak it in enough there? Shina?
I guess so.
I guess so. So here what Shina?
Mhm.
Miss Thomas. I want you to explain it for me from the start to the top. Try a thing. Try a thing.
Okay. Um, so to start, you're applying logs to both sides. Um, well, LG. Oh gosh, Lord, be with me. And then on one side, you can't move over. You can't use the, the power law and move over the x because only b is being raised to the power x.
Nice.
So we're using the reverse of the product law, and you'll end up with um LGA plus LGB to power x,
Mm-hmm.
and your LGY will be a y. Your LGB will be a m. Your x will be a x, and your c will be a LGE.
Right. Now, Shina, something I want to emphasize, right? If you take values, okay, Shane, remember in maths class, I showed you how to plot a graph for a function.
Yes, sir.
Nice. This is not in the form of a line. And so if I put in values for x and I get y values and I make coordinates, do you think I'll get a line when I plot the graph for that? Be honest. Yes or no?
No, sir.
No, you will not. You will not, because it's an example of an exponential function. You will not. However, if I decided to use this function instead, do you think I'll get coordinates that will give you a line?
Yes, sir.
Right. And this graph would be log y versus x. So Shana, this is what would happen. They would give you a table with values for y and values for x. Right? They will give you a table and they will ask you to plot the straight line graph. So tell me, Shana, if let's just say they give you a 7, 5, 3, 2, etc. Let's just say they give you that. You would actually have to convert y to what? See if you could figure that out, Shana. Now, normally you'd plot y versus x, but if you plot y versus x for an exponential function, that's not going to work. So let's just say for this same function, let me just change it up, right? So what if we had a relationship y is equal to 7? What if we had y is equal to 7 by 3 to the power x, right? So Shana, let's just say we had this let's just say we had that function, that exponential function. And they asked you to plot a straight line graph, right? And so let me just say x was 1. When x is 1, that's going to be 3 to the power 1 by 7 is 21. When x is 2, that'll be 9. 9 by 7 is 63. And this could be 3. Be 27 by 7. 27 by 7 is 27 by 7. What that's boy? I think that is 189. and 189 by 7, 1,323, I think. I feel like 4 would be too big for me to calculate in my head, but you get the idea, right? So, Sheena, let me know if you're here now.
Yes, sir.
Right. So, Sheena, do these points look like they would give you um points for a line?
No, sir.
No. A line is a line has a linear relationship, a very simple relationship, and each of the points have some pattern that you can see. But look at this here now. We start off with 1 and get that giving us 21 and 3 giving us what?
1,323.
Isn't like okay, it's common for me, but you would call that exponential growth because how fast it's growing. Yeah? Like
Yes, sir.
how fast it's growing. Yeah, that's an example of exponential growth. So if we plot that graph, you're not gonna get a line. So tell me, Sheena, what would you have to do with y? So what graph would you have to plot to get a line? You'd have to plot what against what? It's on the screen. So,
Oh, in the equation, I mean, in the table now, log y,
right, you'd have
and
to plot log y versus x. So you see, you'd have to make another column, or same column, you'd have to make another row and find log y. So you'd have to put log base 1021, log base 1063, and generate values, and then you'd actually plot that. I mean, if you understand.
yes, sir.
You sure?
Mm-hmm.
Great. Let's do our question. So another question. Or the other case. Okay. So Sheena, you sure you're ready for the next case? It's gonna be a little harder.
I guess.
All right. So put P, let me change up the letters. Put B is equal to CX to the power B in the linear form. So this is the other case, right? So it would generally come in these kind of cases. Um, I guess for now, I should put Y here so as to not confuse you. And you would kind of have some sort of understanding, right? That probably looks less confusing for you. I don't want to just throw into the ocean like crazily. All right. Okay, so let's understand what's going on here, right? Right, Sheena? So in the first case, this is the first case, right? Wasn't X a power? Yeah or no?
Yes, sir.
Nice. X was a power. And that's very different from X being over here.
Yes, sir.
Right, because in this example, X is actually not a power. It's a regular term, right? So you had to apply logs to bring X to the side. You fully understand that.
Yes, sir.
Right. So in this example, X was a power. Right, great. In this example, is X a power?
No, sir.
In this time in this round is a base. But
Mm-hmm.
it's being raised to a power now. B. B is a number, right? It's a constant. The things that are not constants over here are Y and X. So, right, so C and B are constants, right? Understand?
Yes, sir.
Right. So in this example, it's slightly different because X is not a power, but the same properties would hold. Because Sheena, hence if I want to make something in the linear form, I don't want any powers.
Yes, sir.
And what we could use to get rid of powers?
Log.
Logs, correct. Because if you apply logs, you could take the power and move it to the side. Great. So let's apply logs, right? Let's do that. If I apply logs on either side, I'm going to get, so I want you to tell me, right, Sheena? I'm going to get log what?
Um, log y equals log cx to the power b.
Am I going to take that b and move it to the side?
No, sir.
No, no, I'm not, I can't do that. Instead, I'm going to write log, open bracket, c multiplied by x to the power b so you can see it clearly. So what do you think I'll have to do in the next step?
Davis, um, power
Right? So I would say log what?
log c plus log x to the power b.
Right? Mm-hmm. And
And now we oh, sorry.
no, no, sorry for you. You were saying something. You're saying the correct thing. Continue.
Okay, and now you move over the power to the over the log, so it'll be b log x.
Okay. Are you seeing any powers now?
No, sir.
Nice. And just to remind you, C and B um are elements of the real number system, right? So essentially they are numbers. That's what I'm saying. C and B are numbers, right? They just
Mm-hmm.
fancy notation fit. It could flex on and C sec if you see if you want, right? So we need to write it in the final form right now, Shina. So that's what we need to do. So what's the equation of a line again? What's the equation?
Y equals x plus c.
Yeah, y is equal to mx plus c. What are the variables in this particular equation?
Log y
So y, yeah, and what else?
and x.
And x, right? So again, c and b, you're treating that as numbers. So let me see if you could figure it out. I want to put it in the form y is equal to mx plus c. M is a number times x, the unknown, plus c. So you figure it out. What do you think I should write next?
Um,
So tell me, Shina, if you want to put this in this form, right? We have m, which is a number, times a unknown, plus a constant. So look at what you have in this line. We nearly there. We already got rid of the powers. So we just need to put it in the correct order. I know you can do it, Shina.
so b log x plus log c.
Great. Serena, are you able to follow? I'm gonna feel you understand everything so far.
Yes, sir, I understand.
Okay, nice. So if this is the case, right? Tell me, Shina, I would have to plot what versus what if I wanted to get a straight line. See if you could figure it out with me without me drawing the arrows to show you what each corresponds to.
Log y
Versus,
x.
think again.
B log x. Wait, no, that making no sense.
No, no, not correct.
Okay.
Wait, let me show you why. So wouldn't log y take the form, wouldn't that log y be in place of y?
Yes, sir.
M would be, or b would be m, right? And what would be x? Log x would take the form of x, right? And c would be log c. So you understand?
Yes, sir.
You sure?
Yes, sir.
I had to make sure. So if I had a graph, my y-intercept would be given by log c. So I would say c is equal to log c. Nice. And the gradient m would be equal to what?
B.
Yeah. Lovely. So these are the two forms. How are you all feeling about it? Hard, easy, manageable? Tell mom, tell me,
It
Sheena.
wasn't that bad.
Not that bad.
Yeah, talking for so long was my worst nightmare, but it wasn't.
But like, I don't know, you seem like you're a conversationalist. You just like do plenty talking and thing. I don't know why you're feeling so nervous.
I am talkative, but no.
When it comes to maths, it's like no. All right. And before we move on, just some things to keep in mind. All right. So let me adding an additional part for the two questions, right? So let me show you all something. Right. So Shayna, additional part. And you need to know this, eh? This is very important. Like very. Can't stress that enough. So in these type of questions, they would be like, you know what? Find, they would tell you, find for find for the gradient. So find for the gradient, or just put find the gradient. All right, so find the gradient and hence state the value of b. That's one question they would ask you. Another question would be find the y-intercept and hence state the value of c. Right. So Serena, I want you to help me with the first part, right? So Serena, they want us to find the gradient and hence say the value of b. So and you know how you would find the gradient? So like after plotting the graph, and you would just take 2 points and find the gradient.
Yes, sir.
Nice. So when you find the gradient for this graph, um, this kind of hard because we don't have any values to work with, but we could just assume, like, let's assume that the gradient was equal to 2. Could assume that. So if that's the case, Serena, m would be equal to 2, right? So in this instance, m is equal to 2 and m would correspond to b. Yeah or no?
Yes, sir.
Right. So for the first one, if m is equal to 2, that would mean b is equal to,
2.
right? And how did I know that? Well, from the relationship. So the other one is going to be a little harder, right? I'm just warning you. It's going to be a bit harder to see. All right. Now they want us to find the y-intercept. So if we're looking at this little sketch, we could assume it's probably like 3 or something, right? Let's assume, let's assume the y-intercept was equal to 3. Yeah, we
Yes,
are going to
sir.
assume that, right? So if we assuming that, then the graph would look like this. And if at any point I'm losing you like real bad, you go tell me.
Okay.
So wouldn't you agree that the graph would look like that if it had a y in the separate tree?
Yes.
Yes. So you would say C is equal to 3. Now this is the part that kind of confusing. Because I know we have two C's. Let me just fix that. Give me another letter to change C with.
Um. S.
S?
Yeah.
I wonder why. Totally not because your name is Serena, and
Totally not.
maybe because it's for Shayna.
It really was. It really was.
Let me just change this to S so nobody would get confused. So, Shayna, in case you're wondering, I just changing C to S so you wouldn't have any overlapping. You wouldn't be using the same constant, I mean the same letter twice, right? Yeah. So Serena, if I assume that the y-intercept was 3, then I would say C is equal to 3. Yeah or no?
Yes, sir.
But according to the relationship here, what is C equal to? What is C equal to?
Is equal to log S.
Yeah, I have to change this to S. Let me see if I have to change it anywhere else. I have to change it over here. Okay, nice. This looks good. I would have to change. I would have to change. Um, I was saying change. I would have to say that, 3 is equal to log S. On a scale of 1 to 10, how badly did that confuse you, if any at all?
It didn't confuse me at all.
It didn't confuse you, right? Because we understand that for this particular graph, C would be log S. So if we find C to be 3, then we can say 3 is equal to log S. Great. This is the part where students will cry. But you shouldn't cry because we dealt with stuff like this in the past. All right. So Serena, we want to find for S, right? We want to find for S. Yeah?
Yeah.
All right, let me show you how we're going to do that. So what I'm going to do is I'm going to convert this to, I'm going to just write log LG as log base 10. I'm going to write 3 is equal to log base 10 S. If I want to find for S, all I have to do is convert the log form to the log form into the indice form or the exponential form. So Serena, you remember how this is go? If I want to convert that to the indice form, how would I do that?
It would be 10 to the power 3 equals S.
Right. So I think you can see what S is one time. It's 10 to the power 3.
1,000.
Right. That was simple, right?
Yeah.
Right. So a lot of students have a hard time understanding this. Did you have a hard time understanding this?
Not really.
Okay, good. Because we you remember, guys, we would have looked at what the log function actually meant and how to apply it with the base, argument, and the power. So this shouldn't be a problem. Shayna, do you understand how we went from the log form to the indice form?
So I understand how much love is from. But I have a question. You could go back up for a second because my Wi-Fi dropped and I didn't get the note from. Like, yeah, thank you.
No problem. So I was saying, what they would do is they would tell you to find a gradient and hence find the value of the number. I mean, hence find the value of the like B or whatever. And then they might be like, find the y-intercept and hence take the value of C. They like to do that. So Shayna, you had to understand something, right? In this particular relationship, and M was equal to B.
Yes, sir.
So if you take 2 points, when you plot the graph, right? If you take 2 points and you find the gradients, then the gradient would be equal to B one time, right? So B would be equal to 2. We just assuming that the gradient is 2, right? Let me
Yes,
know if
sir.
I'm losing here.
No, I'm following. My
Okay,
first one is practice because I'm writing.
all right. And now in this a bit confusing, but But Shina, what is the what is equivalent to the y-intercept in this equation? Tell me.
Sorry, C.
All right, so C is equal to what in this equation we came up with?
Log 5.
That's S.
Oh, oh,
Yes, Serena.
that
You
is
sure you
S.
didn't you sure you didn't pick S to deceive people? Or maybe that's why I just writing bad. Let me just change this to the that had to be a S, right? Shina, that had to be a S. You can't confuse that with a five.
Yeah.
Right. So Shina, C is actually equal to log S, right? Yeah or no?
Yes, sir.
Great. Great. So when I find the y-intercept, would that give me the value for S or would it give me log S?
When you find the value for what? Sorry.
Okay, when I read off the y-intercept, is it going to give me what S is?
Yes.
No. So watch this again, Shina. If we compare in the linear form to the derived linear form, you would have seen that C is actually equal to what?
Log S.
Is log S and S the same thing?
No, sir.
No. So if they ask you to find the value for S, this is what you're gonna do. So what if we got C to be 3? Right? So if C was 3, right? Then 3 is equal to log base 10s. You understand that LG is just log base 10, right?
Mm-hmm.
So my question to you is, how would I find for S here? That's the question. How would I find for S? So I have the log form. Is it possible for me to go from the log form to the indice form?
Yes, sir.
Right? So in the indice form, it's the base to the power equal the, you remember?
Argument.
Right. And in the log form, it's it's log base argument is equal to the power. So how would I write this in indice form?
10 to the power 3
Mm-hmm.
equals S.
Right. And what's 10 to the power 3?
1,000.
Right. That's the answer. And if you're confused, don't be confused. Watch. If I put it back into this, it would be 3 log base 10, 1,000. And I would have to raise 10 to the power 3 to get 1,000.
Yes, sir.
Is everything making sense?
Yes, sir.
Great. So you need to know that, and let's do it for the previous question. Um, so let's see. So let me just add in an additional part here. I'll assume the same gradients, and we'll see what's gonna happen this time around. So Shina, I want you to help me out here, right? So in the previous case, we had y is equal to ab to the x, right? And this was the equation we came up with. Log y is equal to log bx plus log a. Yeah?
Yes, sir.
They want us to find the gradient and hence state the value of what was the and hence state the value of b. Great. Cool. So Shina, let's assume that the gradient was 2, right? If the gradient is 2 and m would be equal to 2.
Yes, sir.
Right. But if we look at the relationship here, m is actually equal to what?
Log B.
Yeah, m is actually equal to log b. So when you find a gradient, are you actually finding for b or are you finding for log b?
Log B.
Right. How would I find for b?
You would say, well, purposes, for 2.
Mm-hmm.
And then you write the index form.
Right. The ready index form. And if I write that in the index form, what am I gonna end up with?
10 to the power of 2 equals, yeah.
All right, so B would be equal to 100. Nice. Perfect. Sound like we're ready for we finished with logs, right? We finished with logs. Right? Sound like we're ready for some past papers now. Lovely.
Oh,
Yeah, that was it for log quiz on indices. Right? And if they ask you, and if I throw in this part, and if they ask you to find for the value A, right? Let me show you how you would do that, Shina. So Shina, if they ask you to find for A, you'd first need to find for what? See if you can figure it out, Shina. If they ask you to find what A is equal to, what's your very first step? You need to find your what?
round it up.
Yeah, you need to find your y-intercept. Give my value for the y-intercept.
Um, 4.
4. So if the y-intercept is 4, you'd say 4 is equal to log A. And I think you know how this is going to go already, right? So A would just
Yes,
be equal to 10 to the power 4. Yeah,
yes, sir.
great. Good, right? Although what time to copy down the notes, so just move straight into the questions.
Copy down, please.
Okay, no problem. Right, so you'll copy down whatever I didn't have. Great. So as soon as you have that copy down, let me know, and we'll start the log series and indices test one time. Right, so Serena and Sheena, as soon as earlier, finish copying what's on the screen, tell me, moving with speed today.
I have copied down.
All right. So again, there are two forms you need to know. You need to know this form here where x is our power, right? And you need to know this form here when x is our base. Those two forms. Right? So Serena, I said you already copied down this on the screen.
Yes, sir.
All right, Sheena, what about you?
Yes, sir.
Okay, continue.
I'm finished.
Okay, Serena, you finished? So Sheena, what about you?
Yes.
Okay, cool. Um, Shina, would you like me to put you in part two where I ask you to find the y-intercept and explain that, or are you okay with the concept?
I understand the concept.
Right, nice. Serena, what about you? You understand the concept or not?
Yes.
All right, nice.
I'm finished copying it now.
Right? Shayna, just because Serena saying she copied down, just say yeah. Um, let me know if you have everything copied down, Shayna.
No flash ever.
Okay, cool. Copy this down. I'm gonna just change C to S. You can say that, or you can say S and B are elements of the real number system. Anyone is fine. Right. Are you copied on everything? Well, Serena, I have everything copied on.
I had everything copied down already. I was just making like notes in between. So, but Shayna disconnected, so I don't know if she have everything yet.
Talk a little louder.
I said I already had everything written down. I was just making notes, but I don't know if Shayna has everything because she keeps disconnecting.
Yeah, her Wi-Fi is crazy. Don't give her Wi-Fi to hold her baby. Otherwise, you go drop it. Yeah.
Yeah,
Say that again?
I said yeah.
Yeah. Um, so you had this part copied on?
Mhm.
Wait, you have everything copied on. Oh, good.
Yeah, I said I was just making notes.
Okay, okay, cool. All right. Um, the last thing I just want to go run through something. Last thing you should know. Ln is the same thing as log base e. Just remember that. And e is a constant like pi. And the this is called the natural exponent. So e is called the natural exponent, right? And ln is called the natural logarithm. Make a note about that. Let me just make this nice. Right, so e is called the natural exponent, and ln is called the natural logarithm. Just some things to know. So Serena, I don't think I ever asked you what school you're going to, but since you're up from North, what school do you go to? I'm curious.
Lakshmi,
Which school?
Lakshmi girls.
Oh, you go to Lakshmi Girls.
Yeah,
Okay. That's like right by UE.
I know.
Yeah, well, you would know. Yeah, so whenever I get the calculator, I could just give it right there. Because I'll be there all the time. I just drop off there to go into UE.
Oh, okay.
Mm-hmm. You know where the tunnel is?
Yeah,
Yeah, right there. I don't know why I'm asking you, like, you more familiar with the area than me, because I don't live up north. I from south.
oh, that's far.
Yeah, but I staying up north.
Oh,
But the calculator, the one I sent you is in Gulf City, that's in south.
oh,
Yeah. Okay. So we have these things copied on. Let me just check on Sheena, see what's going on. All right, look, Sheena, speaking of the devil. Yes, Sheena, you back?
Yes, sir. Oh my goodness.
Sheena, why don't you turn on your phone? I feel like your phone Wi-Fi, like the Wi-Fi connection with your phone stronger.
All right.
Try that and see what happens.
Yes, sir.
Right, so Serena, I think we could speed through all of the questions. I don't think we finished all, but I think we finished a good bit of it. What do you think?
yeah, I think we're good.
I think I'll focus on the ones that gave you all trouble first. So I was just waiting on Sheena. As soon as Sheena is here, we're gonna start.
Starting way back.
Nice.
Let's say that way.
That's great. Yes, who's back? I don't even know that song.
Yeah.
Who's back? Guess who's back? Da-na-na. Shayna's back. Slim Shayna, oh my God. That makes so much like it actually work. You know, like Slim Shady, Slim Shayna. Shayna is the next big rapper.
You never know.
You never know. All right. It's a shame she didn't like she not here anymore. But she's the next Oppenheimer. Yeah,
Yes.
yeah. We have Oppenheimer, we have next Eminem. Yeah. Serena, what are you?
I don't know.
I feel like Serena is the next Serena. Yeah. I feel like you have a strong sense of individualism. You be yourself. That's good. Okay, so which questions gave you all trouble? I presume this one, like this one for sure. I just give everybody trouble. So I'm gonna do this question first. Anytime,
Yes.
so anytime you see e, which is a natural exponent, it's a constant, you would apply ln on both sides, not log, right? Now, before I start this question, look at what I'm going to do, right, Shina? So I could say that this would be 4e to the power minus 4s minus 3 equal to 10 plus 6. Did I confuse you?
No, sir, because you're constantly 6 0. So you'll add 6.
Right? And what is 10 plus 6?
16.
Right? And if I wanted, I could have divide both sides by 4.
Yes, sir.
Yeah.
So I reach on the last certain point. I just like after the
You
E
didn't know
part
what
of
to
it
do.
now.
You didn't know what to do with that E.
Yeah.
Understand? Right? And what is 4 into 16?
4.
Right. So this is the part where we can't simplify anymore, right?
Yes, sir.
Right. So now we're going to apply the natural logarithm, which is ln, because we have e, easy natural exponent. So we're going to apply ln on both sides. If I do that, I'll get ln e to the power minus 4s minus 3 equal to ln 4. Right? So this is a log, So, don't get confused. Ln is just the same thing. Ln is just log base e. That's all. And e is a number. E is like 2.7 something. It's a constant like pi. Don't get tired. Right? Say with me so far.
Yes, sir.
Right, so we're going to take the power now and bring it to the side. So what am I going to write in my next line?
Um, for ln.
Wait, what?
Oh, for the sorry, crap. I'm not following. Minus 4s minus 3 ln e.
What do you all think ln e is equal to? So I just told you guys that ln is the same thing as log base e. So what do you all think log base e would be equal to?
1.
Shin, I agree. Log base e is 1.
Yes, sir.
Yeah. So in other words, what is ln e?
1.
Yeah, yeah, exactly. So you're gonna end up with minus 4s minus 3 by 1, because we know ln e is 1, equal to ln 4, right? So you're gonna end up with minus 4s minus 3 is equal to ln 4. And where's the next step? Tell Machina, what's the next step? So from here, it's just regular algebra. It's just simple algebra. Promise.
So, yeah, you do minus 45 minus 3, which is
That's Essa.
Also,
That,
oh crap. So your fives look just like your S.
oh, you,
I'm sorry.
you find so?
Yes. Oh
Okay.
my goodness. Just now. I'm writing to my book.
Oh, yeah, I see what you mean. That's, yeah, right. All right, so Serena, what's the next step? Like it's regular algebra from here, right? So you want all the unknown, you want the unknowns on one side, the left hand side, and you want the numbers on the other side, right? So tell me, Serena, what's the next step?
Um, divide both sides by -4 -3.
Not quite. So Serena, this is a regular algebra question, Learn four is a number. Watch. So what I would do is I would just take the -3, move it across.
Oh, okay.
So that'll be minus 4s is equal to ln 4 plus 3. And then I want to find for 1s. So I would divide both sides by -4.
Okay.
Right? So s would be equal to ln 4 plus 3 over -4. That's it. If you're confused, tell me.
No, I understand.
So you understand that ln 4 is just a regular number, right? Like because okay, if you had to do a question like -4x minus 3 is equal to 2. And that's really easy.
Yeah,
But and you could recognize that this and this is essentially the same thing.
yeah.
Yeah. Yeah, if you wanted to solve this, you move across the -3, so that'll be 2 plus 3. So -4x is equal to 5. Then you divide both sides of -4. And yeah, you get your answer. It's the same thing over here. You gotta understand that ln 4 is a number. Watch, ln 4 is actually a number. So it's regular algebra here. Nothing complicated. It's only looking complicated. Shina, I want you to run through this thing and let me know if you're real confused. Are you okay?
I'm okay with it, so. I understand.
Okay, you sure?
Yes, sir.
You sure? Or you sure? Or you I don't think I get your joke.
Sasha.
Ah. Serena, you get the joke?
Yeah.
Say this word for me.
Ensure.
Yeah. You sure or you ain't sure? Nice. All right. So let me show you another way you could work this question out. That was one way you could do it. Or we could have just apply ln to all of the terms, right? And if I did, so Serena, why help me with this one? So if I apply ln to every single thing, what would I end up with? That would be ln 4 e, right? Minus 4s minus 3. But you see, you wouldn't be able to do that. You could only apply logs when there's one term on either side. So you can't do this. Can't do that. Nah, never mind. You can't do that. So Serena and Sheena, yeah, let me give a little example of what we're talking about, right? So they wouldn't be lost. And when you work in questions like these, wait there. And when you work in questions like these, right? And you could only drop logs when you have one log on either side. Yeah or no?
Yes, sir.
Oh look Sheena name. Big up Sheena. What are the odds? Right. So you could only drop logs when you have one term on either side. So it's the same thing. You could only apply logs when you have one term on either side. So, Shina, do you understand how I got to to this point where I had one thing on either side?
Yes, sir.
Right. So that if that's the case, you should be able to do question two then. So Shayna, run through question two with me. Fast. Like you've seen both.
Alright.
Yeah. So I need first things first, remember, I need one term on either side. I can't have like over here we have two terms. We can't have that.
Yes, so you subtract 8 on both sides.
All right, so that'll be right, and that'll be 18,
Then you apply logs.
right?
So log 16, p plus 1, and log 18.
Right?
And then you write log 16, p plus 1 as p plus 1 log 16.
Yeah.
And then you divide um log 16 on both sides.
Nice. I like what you're doing. So if you wanted, you could expand, but
Or
that's the best thing to do. It's the best thing to do, right? So you end up with p plus 1 is equal to log 18 all over log 16. What's the next step?
you could write the log 18 over log 16 as
Nope. Nope.
oh,
If it was log 18 minus log 16, then you could write that as log 18 over 16.
no, I was going to answer as log log with like the what?
Oh wait, you want to use the change of base formula? So you want
Yes,
you want to
that
say
was handle.
you're gonna say log base 16 18.
Mm-hmm.
Oh, okay. Bad, big up you. So p plus 1 is equal to log base 16. Now some teachers not so intelligent, I'll be real. Like some people finish their degrees and they just teaching casually, like I trust all your school teachers like smart and they know about the change of base formula. So like if you do this in if you do this and they ask you what you do, show them the change of base formula, right? Most students will do this. Like this is fine. Like all you're doing is like extra and it's like extra skills, right? It's correct though, right? So that'll be log base 16, right? So here what? LG is understood to be log base 10. Right? So if you change in base, you actually had to write log now because it's no longer LG. LG is log base 10. So you got to write log base 16, 18. Understand?
Yes, sir.
Right? And then you move across the plus 1 and you're going to end up with log base, let's see, you have put log base 16, 18 minus 1. Or don't say log base 16, 17. Eh? Don't say that. It's 18 and this 1.
Yes, sir.
I don't do that. Do that. Right? Serena, do you understand everything I did for this question?
Yes, sir.
Nice. Now, how would I check if my answer is correct, Gils? How would I check if my answer is correct?
And you could plug it back in to the original.
Right. Now, if they ask you for the exact value, you'll give them this. If they ask you for the answer to two decimal places, what would it be? Somebody tell me the answer to two decimal places. Right, so log base 16, 18. Right, so that'll be 1.04 to two decimal places. Um, can you can any of you Gils confirm that?
Yes, sir.
All right. And for the other one, s is equal to ln 4 plus 3 over minus 4. What is that equal to two decimal places? Serena or Shina, somebody tell me. S is equal to what? The two decimal places. Did you all find Lon in the calculator?
Yes, so one second.
You're still trying to find it. Is is right. Let me annotate. Is here. You see it, Shina?
Yes, sir.
Yeah. Serena, it should be around the same place in your calculator. So you all are going to press the fraction button. Then you're going to press ln 4, close bracket, plus 3 over minus 4. So, Sheila and Serena, press equal and tell me what you get.
Minus 1 point. It'll be, well, the thing, so you'll say 1.10.
Correct. Serena, can you confirm that?
Yes, sir.
Great. So let's just check if these answers are correct, right? So the first one, if I put the exact thing into the equation, I should get 26. I should. So if I put 16 to the power of log base 16, 18, right? Minus 1. So all you understand that whole thing is P, right? That whole answer is P. Do we understand that? That entire thing is the answer for P. Serena, you understand that?
Yes, sir.
Right? Gonna put that in brackets. And then I'm gonna put plus 1 because it's P plus 1 as the power, right? Okay. Plus 8. So when I press equal, what am I supposed to get? Tell me, Serena, what am I supposed to get?
26.
Maths is very cool. Big up maths. Get 26. Nice. And for this one, here what? I'm just gonna store the value for S. So that's ln 4. So we have that was ln 4 plus 3 all over minus 4. Right? Store A, bam. Let's plug it back into the equation and we should get what? What should I get when I plug it in? So you know what am I supposed to get when I plug back S into this equation?
10.
10, right? Fingers crossed. Bam. Get back 10. So without a doubt, Serena, we're 100% correct. For sure. Right. So Shayna, everything did work out. Our answers are undisputedly correct.
Right, sir.
Which other question gave you all plenty trouble? I feel like I should do the graph questions with you all because that's the latest thing we did. What do you think?
Yes, sir.
All right, so let's handle this question. Express y to the power 3 is equal to 10 to the power x minus 3 in the form log base 10y is equal to ax plus b. Wait, boy, Shayna Wi-Fi. Wait, that Wi-Fi dread, boy. Boy, oh boy. Hmm. All right, so Serena, since you're the only one that's consistently here, um, I needed to unmute.
Okay.
I'm gonna put on my earbuds so I could hear you. Okay, try talking, Serena.
Hello?
Yeah, hello. I hear you.
Okay.
Nice. So first things first, they are giving us an exponential equation, and we need to convert that into a linear form using log base what? What log base do you think we have to use?
Log base 10.
Yeah, we have to use log base 10. So I'm going to apply log base 10 on either side. I'm going to say log base 10 y to the power 3 equals log base 10 to the power x minus 3. What do you suppose is the next step?
You bring the power to the side.
Right? So I could write 3 log base 10 y, and that'll be equal to what?
Open brackets, x minus 3, close brackets, log base 10.
Nice. So I'm gonna write back 3, right? I'm gonna write back 3 log base 10y. And tell me, what is log base 10?
Mm,
Australia?
1.
1, right? So you're gonna end up with 1 by x minus 3, which is just x minus 3. So what do you suppose is the last step? We're nearly there. We're nearly in the form that they want.
I divided both sides by 3.
Correct. Divide both sides by 3. Right? Now, for the sake of this question, we could say divide by 3 like this. Now, if you do it like the other way, that's fine. You just have to separate it into individual fractions. That's correct. But I'll do it like this. So log base 10y, and that would be equal to 1 over 3x minus 1. Did that confuse you?
No, sir.
Okay. Do you understand that you'll get x over 3, which is the same thing as 1 over 3x.
Yes.
Nice. So if that's the case, can you tell me the values for A and B? I'm just curious. See if you can tell me the values for A and B.
A would be 1 over 3 and B would be -1.
Yes. Shina, your Wi-Fi real sabotaging your boy.
So it's hard something against me.
Yeah, like,
Um,
more vendetta against you.
I agree.
But let me know if you understand everything we have on the screen.
Yes, sir.
Okay, cool. Right. So Shina, while you're here, um, I want you to tell me if a graph of log y was plotted against x, what would be the gradient, the y-intercept from the equation above b? Tell me that, Shina. So what would be the gradient? Do you know?
1 over 3.
Right, 1/3. For anybody that might be confused, watch. If we compare this to the y is equal mx plus c form, you will see a direct relationship. Y is equal to mx plus c. So you'll see that y is actually log base 10y. You'll see that m is actually third, x is just x, and c is what? Tell me, Shana, what is c?
-1.
-1, right? Nice. So the gradient, right? So the gradient m, Right. So, Serena, you don't have any problems with that, right?
No, sir.
Okay, good. Now we have to sketch a graph. So what's going to go on the y-axis,
Log y,
right? And what's going to go on the x-axis?
x,
Nice. Is that positive gradient or a negative gradient?
negative, no,
So,
positive, positive.
right, positive, that's it. So you need to know what a positive gradient and a negative gradient looks like. So that'll be log y, and this will be x. Now, just to give you a reminder, a positive gradient would always be in this direction. And how do you think a negative gradient would look like?
It would be the opposite. So from high to low.
Yeah. And the easiest way to think about it is like what you just said, right? If it's positive, and to go in from being sad to happy,
Yeah,
and if you're negative, you go in from being happy to sad.
yeah.
Great. And what was the y-intercept?
-1,
Right. So we know that we need to have a gradient in this direction, and it has to pass through what on the y-axis?
-1.
Right. So look at something like probably like, yeah, that's fine. And I would say that this over here is what?
-1.
Correct. Yeah, that's that. Sheena, did the graph part confuse you?
No, sir, but you gotta explain the positive gradient thing and the negative.
All right. So all positive gradients would be in this direction. All negative gradients would be in this direction. Um, is more so something you gotta remember. I can show you a little way to remember it. Let me show you a little proof of it fast. Let me show you a little proof. So Shana, and we know that this is positive, positive, this is negative, this is negative, yeah.
Yes, sir.
Okay, so if I draw a gradient like this, think of it like a positive divided by a positive. It's a positive divided by a positive,
A positive.
right? And it's also in the third quadrant. What's a negative divided by a negative?
A positive.
Right. So if you have a gradient in this direction, it's a positive gradient,
Okay,
right?
yeah, I understand. Mm-hmm.
And if it's in the other direction, like this, well, a gradient is just y over x, right? Think of it like that. Um, this is the simplest way to remember it. If if you have a negative gradient, it will exist in the second and the fourth quadrant. So think of it like this. It's a positive divided by a negative.
A negative.
Same thing over here, right?
Yes, sir.
Yeah, so this is how a positive gradient would look like. Right? So all these are positive gradients. Anything in this direction is a negative gradient.
Yes, I understand.
So they ask us to sketch it. So I had to put the y-intercept. So I put that there, -1, and I just showed them that it was in the direction of a positive gradient. Cool. So I hope you understand that, right? Did you? Serena? Oh wait, no. Okay, now go on. All right. Serena, while we're at it, let we handle question three, shall we? So how would you work out question three, Serena?
Well, first, I wrote open brackets 2x close brackets 2 multiplied by 2 to the power of 1
right? So you would have split it up using the rules for indices, right?
Yeah.
So that's what you would have do, right?
Yeah.
Right? Minus 2, I put that in brackets. Actually, it don't matter because you're multiplying everything. Doesn't matter, right? So that'll be minus 2 to the power x multiplied by 2 to the power 4. And could you tell everybody what rule for indices you're using?
Um, it would
Yes,
be,
Serena, which rule for the indices you're using?
I don't know the name for it, but I know it's a to the power of m multi plus a to the power of n equals to, wait, hold on, I think I say
You
it
said
wrong.
plus. That's you're supposed to multiply.
Yeah, it's supposed to be multiplied, so it would be a to the power m multiplied by a to the power n equals to a m plus n.
Nice. So anytime you have the same base and you're multiplying, you add the powers.
Yeah.
Right? Plus 14 equal 0. Great. Now, you see 2 to the power 2x? And I could write that as 2 to the power x all squared.
Yeah.
Right? So
So,
this is the question where you would have to do a substitution.
yeah.
Right? Minus 2 to the power x. 2 to the power 4 is 16. Alright, so let me know if you're okay with everything so far. Did you have this?
Yes, sir.
Okay, nice. Now, if you notice, and you see in 2 to the power x in multiple spots,
Yeah.
so we could say let what?
Let's 2 to the power of x be y.
So if I do that, I'm going to end up with 2y squared mhm, minus,
Minus 16y
yeah.
plus 14 equals 0.
Now, if I wanted to simplify this to make factorization a bit easier, what I could divide throughout by,
You could divide by 2 throughout.
right? Because all of them, all of them are divisible by 2. 2 is a factor for each term there. So if I divide by 2 throughout, I'm going to end up with what?
You'd end up with y squared minus 8y plus 7 equals 0.
Right? To get y squared, I would say what by what?
Y by y.
And what number would multiply to give you a positive 7, but add to give you minus 8?
1 and 7.
Okay, but what and 7, if you add it together, I wouldn't give minus 8.
No.
So 1 by 7 would give you 7, but there's also another number. There's also a product of two other numbers that would give you positive 7. You know,
I didn't do it like this.
you do it using the AC method.
No, I don't know what it's called, but I did the thing where you put x equals negative b plus or minus the square of so and
The
so.
quadratic formula.
Yeah, cause
You do all that for this?
yeah, because
I'm not judging it, but because I had this meme. It's like when you use the quadratic formula for like something you could factorize. Yeah.
I don't know what was going through my head. Well,
Well, Your first thought should always be to see if it could factorize, right? Now, Serena, I promise this is not hard to factorize, right? I promise.
Okay.
Look, let me show you what I mean. So, n plus 1 by plus 7 will give you a positive 7.
Yeah.
Okay, what's two other numbers I can give you a positive 7?
-1 and -7.
Right, if I add minus 1 and minus 7, what am I going to get?
-8.
Yeah, so that's it. What, y minus 1, y minus 7, right? If you say that, y would be equal to what?
1,
Y would be equal to?
7.
Yeah, that's it. How you feeling about that?
I feel like I did a whole sort of unnecessary working.
I feel so, yeah, yeah. Because it's a formal question. More than likely, it will always be that you could factorize it. Now, Serena, are both solutions valid in this case?
Um, when I did it, I got y equals 1 is invalid. Well, yeah,
You got y is equal to 1 to be invalid?
yeah.
How come?
Because when I substituted it in and worked it out, I got -28 equals 0. And well, that wouldn't be right.
Hmm. Let me see. Let me see. Interesting. So you said when you plug back in your answers, one of them was wrong?
Yeah,
Okay, let's see. So remember we said that y was equal to 2 to the power x. So you're gonna say 2 to the x is equal to 1, and then you're gonna say 2 to the power x is equal to 7. Yeah?
yeah.
Nice. Is this a case where we would have to use logs?
No,
Well, at least not for the first one, right? Um, so I have 2 to the power x, and 1 could be written as 2 to the power 0.
yeah,
So x is equal to what?
0.
You
Oh,
confused or you understand?
I understand. I don't know why I did it in my book though.
So like when anytime you see an exponential equation with one unknown, your first thought should be, can I write the bases as the same? Because if I could do that, then I could just equate the powers. So 1 is the same thing as 2 to the power 0, so x is equal to 0. So you okay with that, right?
Yeah,
Now, for this, and you agree that, we wouldn't be able to write 7 as 2 to some power,
yeah.
so we should probably use logs there. So if you're using logs to find the power, x would be equal to what?
X would be equal to log base 2, 7.
Right. And if you wanted, I just showed you that you could apply logs on either side to find for x. And I could also do it like this. I could say log 2 to the power x equal to log 7. And you could write out as x log 2 is equal to log 7. And then you just divide both sides by log 2. And you get your answer.
Yeah,
And if you use the change base formula, well, you're going to get back the same thing. So if you can see it like that, that's fine. Because all you're doing there is you're converting from the index form to the logarithm form, which is fine. The teacher can't tell you anything for doing that. You're just stronger. You're just better, you know? I don't know if you ever watched The Boys with Homelander. Did you?
no, I don't think so.
You know?
No,
No, you know that one meme where like the guy was like, I'm stronger, I'm smarter, I'm better. You know what I mean?
yeah,
Yeah, that's from The Boys. I do recommend you watch it, do it. Kinda crazy.
oh,
Kinda
okay.
crazy show. It's basically what would happen if people actually had superpowers, corruption and whatnot.
Okay.
Right? So I want you to find log base 2 or 7 and tell me what you're getting. And tell me your answer the two decimal places. You got 2.84?
81.
0.81. Nice. So let's see if the answers are correct, right? So 2 to the power 2 by 0 plus 1 minus 2 to the power 0 plus 4 plus 14. What should get when I press equal?
0.
Yep, I do get 0. That's a valid solution. And then what if I replace 0 with log base 27, which is the exact answer for the other solution? Bam. Again, back 0. So are both of the answers correct?
Yes.
Nice. You know, wait to look at that and tell me if you understand it.
Yes, I understand.
Okay, good. Thank you, Master Khan. All right, cool. Yeah, we'll continue. Oh, you can see how obsessed I was with maths. Like last night, I fall asleep to this video. Like I fall asleep to this video. Just be looking at maths videos the
So
whole
that
day.
is not healthy.
What you say?
That is not healthy.
I know, right? But like I fall asleep like a baby. Like I sleep good. I sleep real strong. That's why I didn't wake up in time. Yeah. Mhm. Right. Here, let me continue. So, was there any other questions I gave you all trouble? Were you able to figure out the first question? I think Sheena had some trouble with the first question.
I did as well.
You did as well?
Yeah.
Okay. So Sheena, try to make your internet work because I'm gonna
Yes,
give you a
sir.
question.
At this
I'm gonna
rate, I will be working over class.
At this point you could just watch over class.
Yes.
Yeah, I don't
Right.
blame you. Right, so this gave you all a bit of trouble. Yeah. So let me just tell you how this is go, right? You want to end up with one log term on either side with the same base. That's your dream. That's the mission. You want that. So your objective here should be to end up with one log term on either side. And it must be the same base. To do that, you need to apply the rules for logs, right? You need to apply rules for logs. Right. So if you don't have one log term on either side, that's as simplified as possible. You can't do anything at all. First things first, let's look at the left-hand side. So Shina, on the left-hand side, we have log base 7 terms, and you're adding it. So we're going to apply what rule there?
Yeah, on product.
Right, so you're gonna end up with log base 7, 2x plus 3 by 2x plus 3, and I'm going to put an extra pair of brackets, so let's not confuse anybody. Because when you expand this whole thing, that whole thing is going to be to log base 7, right? And that's going to be equal. This is the part that might confuse some people. So Serena, did you know that you had to apply the power rule to take this 2 and bring it to the argument?
Yes.
Okay, good. Well, if you didn't know that, you should have got through. Uh, uh, I'm curious as to know which part make you stumble. Curious.
Honestly, I don't know. I just get confused halfway through, but I still did what I thought was right.
So far you had everything. You have everything I have, right?
Yeah.
Okay. Well, you will let me know what point things went downhill.
Okay.
So we have this, right? And can we all agree that we now have one log term on either side? Yeah or no?
Yes, sir.
Right. Serena, how much log term is seen on this side?
One.
And on this side, one. So what are we allowed to do at this point in time?
Drop off the log terms.
Right, we're allowed to drop it off. So drop logs. I'm going to write 2x plus 3 by 2x plus 3 equal to 2x squared. So let me expand this. So Serena, if we expand that, it's going to be 2x by 2x, which is 4x squared, then 2x by positive 3, 6x, and 3 by 2x, which is 6x, and then 3 by 3, 9. Tell me if you're following with me so far.
Yes, sir.
Okay? And do you understand how I got 4x squared?
Yes, sir.
Cool. Right? Okay, now, anybody, in case I'll be confused, 2x squared means 2x by 2x. So 2 by 2 is 4, and x by x is x squared. Right. So, Serena, is this the part where your brain kind of got fried?
Yeah.
All right. So, Serena, we're trying to find for what?
X.
Now, I understand why you might be confused. Wait, I don't realize I make a wrong mistake. It's supposed to be plus 9 over here, hence.
Yeah.
Yeah. Share what? Serena, you're kind of confused. You don't know what to do next.
Yeah.
Right? Shayna, what about you? Do you know what you have to do next?
Yes, sir.
All right. Well, Serena, stay with me, right? So, Serena, we have an x squared term here. And you think we should don't you think we should move across our x squared term to be by the 4x squared?
Yeah.
Because into these questions, you typically would make a quadratic, and a quadratic equation is being the form ax squared plus bx plus c is equal to 0. Equal to 0, right? Remember?
Yeah.
Okay, what? Let's take our 4x squared and bring it by the other 4x squared. If I do that, if I take 4x squared and I move it across, what is that going to turn to,
It's gonna be turned to negative 4x squared.
right? So 4x squared minus 4x squared, right? Oh, sorry about that. And then we have 6x plus 6x. What is 6x plus 6x?
Positive 12x.
Right? Plus 9. And we moved across everything that was on the right-hand side. That's going to be equal to what?
0.
It's going to be 0. Hmm. What is 4x squared minus 4x squared?
0.
Nice. So what's the only thing we remain with? The left-hand side.
12x plus 9.
Think you know what to do from here?
Yeah.
What should do next?
Move across the 9. So you will get 12x equals negative 9. And then divide both sides by 12.
Right? X will be equal to minus 9 over 12, which simplifies to what?
3 over 4.
Right? I mean, if you understand that.
Yes, sir.
Yeah. How do you feel about that?
better now.
So,
I keep forgetting that it would be equal to 0. That's the part that always throws me off.
like when I move across this,
Yeah.
okay, another way to think about it that would help, that would cure the confusion is what you're really doing, like mathematically, what you're actually doing is you're minusing 4x squared on both sides. That's what you're actually doing.
Oh, okay.
So, watch, let me give you a simple example. If I have x, if I have x plus 5 is equal to 9, and I want to find for x, I would have to minus 5 both sides. So if I'm doing that, that would be x plus 0 is equal to 9 minus 5, which is 4. Understand?
Yes, sir.
Yeah. Um, if I had x minus 7 is equal to 3, what would I need to do on both sides to find for x?
You'd need to minus 7 on both sides.
No.
No?
Why you would say that, but not
Add
quite.
7.
I
Add
would have
7.
to add 7. Because if I want to cancel off the minus 7,
Yes.
yeah. So do you understand now why it would be 0? Because if when you quote unquote moving it across, you're actually taking away 4x squared on both sides. So I choose to put the negative 4x squared over here. But if I were to write out the full thing, it would really be maybe 4x squared minus 4x squared. And well, the next line, that would be equal to 0.
Okay, I understand.
Great. Right? So sometime to soak that in. We have 2 more questions to do. And that's it. And after that, we have some time to do some harder questions. And you're good. Like, so today, I sure you're good. I sure you're good with logs. Like, I sure. At least, I feel like if only do a log exam, at least you'll get like 70s or 80s. Like, worst case scenario. Oh, Serena, higher than that or lower than that?
Higher.
I like that spirit. You're a positive gradient.
Yeah.
Right, so see if you can do question B. If you did, well, Serena, you sent me your work in. Let me check
Yeah.
what you do for question B. Say you apply the quotient rule and you wrote 1 as log base 2, 2. Excellent. And then you said, wait, what? Mm, ah, okay, so Serena, we gotta work on yeah.
Okay.
You typically drop the logs first and then do the operation.
Oh, okay.
Yeah, like look at this example. Notice I dropped the logs as soon as I could have.
Yeah.
Yeah. So here what? Serena and Shayna, I want you all to do back part B. Right? So Serena, here's the general flow to follow.
Mm.
You're going to apply the rules for logs, right? You're gonna apply the rules for the logs. You want one log on either side, and as soon as you have that, drop the logs and continue.
Okay.
Now what you did, you should still get the same answer, but is not how you would write it mathematically. Because they come like you inserting something into the log function. You can't do that. Let me show you what I mean, Serena. I need to show you what I mean. If I have log base 2, 5x minus 4 all over x plus 3, right? And that's equal to log base 2. Enter at a position where I could just drop log base 2.
Yeah.
But you decided to multiply both sides by x plus 3 n's.
Yeah.
Let me show you what happen if you do that. If you multiply both sides by x plus 3, it's not going to have the effect you think it's going to have. Because if you do that, you're really doing this. That's what you're really doing.
Oh,
And that's not what you want. I can tell you why that's not what you want. Because if I apply the power rule, you'll see that's crazy. That's not going to cancel off the way you want.
mm-mm.
Understand?
Yes.
So what you would have to do is you would have to drop the logs first and then find facts. So
Okay.
I'd like you to try back question B in a similar manner to question A.
Okay.
All right, so Serena, you have real potential. You just have to like channel it and make sure you're doing the correct thing. So
Okay.
yeah, I can see the potential in you, right? Like if you was able to convert one to log base 2, so that was good. I was good that I did that. While I'm at it, let me just check your other working. So for the first question, I saw that you dropped log 7, great. And but like look you get the answer though. For the first question, look you get the answer for part one. But you said it was invalid.
Yeah, I don't know what was going through my head. I was doing all these questions when I was like very tired. So
No, no,
I
no, no, no. I understand why you thought it was invalid because it's negative and you can't find log of a negative number, right?
yeah, but it
Actually,
doesn't.
you're correct. You're correct. This question, the kind of cuckoo, it's actually an invalid answer. You're correct. Because if I plug this into, say, it's 2x over here, you can end up with negative 6 over 4, and you can't find log of negative 6 over 4. This solution is actually invalid, right? Invalid solution. So excellent job, right? That invalid solution, and I could give you a reason why, right? Example. So great job there, Serena. So Serena, you did everything correct with the first question, so great job. The second question, you got the correct answer, no, it's just that you will lose mark for the working because remember I showed you what would happen if you multiply both sides by x plus 3.
Yes, sir.
It wouldn't have the effect you think it would have because you applied it inside the bracket sense.
Yeah.
Yeah, but you can't do that. You can't do that because that is inside the log function. You can't do anything with that. You could only interfere with the entire function. So always drop logs first. So I've given you 2 minutes to do back question B and send it back to me. I didn't even realize the time is 11:39. But I just making up for I already make up for the time that we missed, right? So I'm gonna do question B and that'll be it. Yeah.
I sent you my working.
Say that again?
I sent you my working.
Oh, you sent me looking, I'm gonna check it out. So yeah, you drop the logs, multiply by the way, you don't have to say you might write this, eh?
I don't have to?
You just write multiply by x plus 3.
Okay. My math teacher usually writes it the way that I wrote it, so I kind of
Ah,
got into the habit of doing it without knowing.
like I will tell you something, right? You should write it like that if it's in a question. So like if it's in a question, but you see how you're putting it to the side? Like okay, you put in that to show somebody that you're multiplying the entire thing by x plus 3. You don't have to, but it's fine. I mean,
Okay.
you're not wrong mathematically. It's not wrong. It just you just see that. But it's fine.
Okay.
Okay, let me handle up this question quickly. So that would be log base 2, 5x minus 4 all over x plus 3 equal, I would change 1 log base 2 to such that we had the same base. So we have one log on either side, so now we could drop the logs. That would be 5x minus 4 all over x plus 3, right? And that would be equal to 2. From here, you could multiply both sides by x plus 3. Or how I would do it, I would just say it's a cross multiply, right? But either one is correct. I'm going to cross multiply. If you multiply both sides by x plus 3, you know what? The x plus 3 and the x plus 3 will cancel off on this side, and you're going to end up with 2x plus 6 on this side. Sure, that's correct. I find like students to see cross multiplication better. I don't know why. I really don't know why.
I used to be very confused with it.
Oh,
Yeah.
what you're doing is just multiplying diagonally. So we have x plus 3 here by 2. What is if you multiplied everything in x plus 3 by 2, what would you end up with,
2x plus 6.
right? And then we have 5x minus 4 by 1. Anything by 1 is itself. If I ask you, is a million times 1? You tell me a million. What do you think 5x minus 4 by 1 is,
Just 5x minus 4.
right? And then I would move across all x terms to the left-hand side. See this 5x? I'm going to move across this 5x. See that plus 6? I'm going to move across that plus 6. So I'm going to end up with 2x minus 5x. And that would be equal to what? Tell me, Serena,
Negative 4 minus 6.
right? What is 2x minus 5x?
Negative 3x.
And that would be equal to minus 10. Yeah, I would just divide both sides by minus 3. Right, so x would be equal 10 over 3. I'm gonna if you're okay with that result.
Yes, sir.
Right, and if you put it back into the brackets, you'll see that you'll get positive results for everything. So it's a valid solution. So I'm gonna if you're okay with that.
Yes, sir.
Right? Before I end class, let me just do this question because that if we do that, we finish with the log and indices test. Because it was 1, 2, 3, 4, it's 5 pages, right? Serena, did you do the graph question for homework?
Yes, I did.
Okay, I'll check out all of that. Right? So with this question is just like okay, this question is just a glorified algebra question. The other question similar to this. I think it was 2017, was it? No, 2019, right? So, Serena, let's handle up this quickly.
Okay.
So anytime I have logs and I have a power, what am I allowed to do with power?
You could bring it to the side.
Right. And if you want to find for x and you want x to the side,
Yes.
yeah. So I could write this as 16x log 8 plus what?
Plus 3x log 2.
That would be equal to 4. You see, this question different from the other questions because usually you'd have to apply logs, but there's already logs in this question. So you could take the power and move it to the side one time, right? Yeah. Serena, are you seeing anything in common with 16x log 8 and 3x log 2?
Yes.
It's seen in common.
8 could be written as 2 to the power 3.
Oh, you did. That's an interesting way to think about it, right? Yeah, you can do that. There's multiple ways you can think about it, right? If you wanted, Serena, you could take this tree and bring it up to the top, and that'll be 16x log 8 plus x log 2 to the power 3, which is log 8, equal to the power 4, and you'll get 17x log 8 equal to 4. You see how I did that?
Yeah.
But instead you would have said 2 to the power 3, and the next.
Then I brought the 3 to the side and it will be multiplied with the 16x and it will become 48x.
That's correct. Perfect. So much ways to work this question out there. So much ways. 8 is the same thing as 2 to the power 3. Take that 3, move it to the side. That'll be 3 by 16. What is 3 by 16?
48.
48, right? Then I put 48x. 48x log 2 plus 3x log 2. So what's the next step from there, Serena?
Then I added 48x and 3x.
Right? Because both of them, check it out, right? This is 48 log 2's, and this is 3 log 2's. So altogether, you'd have 51 log 2's x. Yeah,
Yeah.
you got 51 x log 2. That would be equal to 4. I want to find for x. So what shouldn't be on this side?
The 51 and log 2.
Right? So I could divide by 51 log 2. Right? So the 51 log 2 would cancel off with the 51 on the log 2. And that will leave you with x. So x would be equal to 4 over 51 log 2. You get that?
Yes.
Nice. Now I need to explain something, right? If they don't ask you, like if they don't specify what they want the answer to be, you could leave the answer in the exact form. If they specifically say give the answer to two decimal places, you'd write the answer to two decimal places. You can leave your answer in that form, right? But if I did round it off to two decimal places, could you tell me what I would get?
Sure.
What is 4 over 51 log 2?
I got 0.26.
Right? And that's not the only way you can work this question out. I can speed run this question in another way. I could say 16x log 8 plus x 2 to the power 3 is equal to 4. Right? That would have been 16x log 8 plus x log 8. That'll be equal to 4. I think you see where I'm going with this. And I could write this as 17x log 8. Come a year or no? Yeah, I could do that. And I would end up with, I would end up having to divide both sides by 17 log 8. I know the answer will look different, but it will mean the same thing. So in this case, x would be equal to what?
4/17 log 8.
And I want you to understand something, right? If I change the 8 to 2 to the power 3, and I multiplied 17 by 3, what would I get?
51.
Bam. And same thing over here. If I wrote 51 as 17 times 3, and I brought up the 3 to over here, I would get 17 log 8. You understand it's the exact same thing, right?
Yes, sir.
Great. Great. And this 2 be equal to 0.26. Right, so you okay with that?
Yes, sir.
Nice. So I will send the solutions. You will go through the solutions, right? You will go through the solutions and you will see if you shared everything I had. And just because I have a real thing to do, right? I have a master's to study for myself. So I'm trusting that you would go through the solutions. If you have something that I don't have a chance that it could be correct, you just do it a different way, message me, um, and tell me, and I will check through the specific question, right?
Okay, sir.
Yeah. Right, Shayna, I'm gonna send you working, do the same thing. And you go watch the recording too.
All right, so yes, I need to watch your recording.
Yeah. Right? And it still have extra practice, possible questions over here. You see this question? Well, let you do this question. I really want to let you do this question. It's a tough one. It's a tough one. May, June 2017, a tough question, right? And just to specify, to say something, right? If they don't specify what they want the answer as, I would advise you to leave the answer in the exact form. So, by exact form, mean like this. They don't specify how they want the answer, give them the answer in the exact form, right? Or was a fraction. If they actually answer the two decimal places or three decimal places, then round off. But under normal circumstances, leave your answer in the exact form. Yeah? Okay?
Okay,
Yes,
sir.
sir.
Alright, I'm gonna send these notes on. Yeah, thanks for coming to class today, guys or girls. See you later
Bye, sir.
next week. Bye bye.